Imagine a car that never needs refueling for an entire century. That's the revolutionary promise of thorium, a rare yet powerful radioactive mineral. Set to debut in 2030, these thorium-powered cars will be able to run for 100 years, using just 8 grams of thorium, completely eliminating the need for traditional fuels like gasoline or diesel. What is thorium? Thorium is a chemical element with the atomic number 90, belonging to the actinide series on the periodic table. First discovered in 1828 by Norwegian mineralogist Morten Thrain Esmark, thorium has long been recognized for its potential as an alternative nuclear fuel. It is a naturally occurring radioactive metal, found primarily in the Earth's crust, often in conjunction with rare earth minerals. Unlike other radioactive materials, thorium is relatively abundant and more evenly distributed across the planet. Why thorium could be the fuel of the future? Thorium offers several key advantages over traditional nuclear fuels like uranium. Energy efficiency. Thorium's energy density is extraordinary. A small amount, just a few grams, can generate immense amounts of energy. In fact, 1 gram of thorium can produce as much energy as 28,000 liters of gasoline, and 8 grams can power a car for a century. The potential energy yield from thorium is estimated to be about 20 million times greater than that of coal per unit mass. Environmental friendliness. Thorium is not only energy dense, but also far cleaner compared to fossil fuels and even conventional nuclear power. When used in thorium reactors, the process produces significantly less radioactive waste than uranium, and the waste decays much faster, becoming safe in a matter of centuries instead of millennia. Moreover, thorium-fueled reactors do not produce harmful greenhouse gases, making it an environmentally sound option for the future of clean energy. Safety. Thorium's radioactive properties raise concerns for some, but scientists have addressed this by highlighting its inherent safety features. Thorium reactors operate at low pressures and are inherently resistant to meltdowns. Additionally, thorium cannot sustain a chain reaction on its own, making it a safer option than uranium, which can lead to catastrophic nuclear accidents. For car applications, shielding materials such as thin aluminum sheets are more than enough to block any harmful radiation, ensuring the vehicle is safe to operate. Abundance. Thorium is about 3 to 4 times more abundant in the Earth's crust than uranium. It's found in large quantities in places like the United States, Australia, India, and Norway, making it a globally accessible resource. Its abundance ensures that it can be sustainably harvested for energy production without the geopolitical tensions often associated with other energy resources, like oil. How does a thorium car work? The core technology behind a thorium-powered car would be based on a miniaturized version of the thorium molten salt reactor (TMS) or concept. Here's how it could work. Energy production. Thorium is used as a fuel in a molten salt reactor, where it is bombarded with neutrons, transforming it into uranium-233, which then undergoes fission to release large amounts of heat. This heat is used to drive a turbine that generates electricity. No refueling needed. Since thorium produces such a high energy yield, a car with just 8 grams of thorium could theoretically operate for 100 years without requiring additional fuel. This means no trips to the gas station and no concerns about running out of energy. Minimal maintenance. The durability of a thorium-based energy system means that these vehicles would require far less maintenance compared to traditional combustion engines. The complex system of fuel pumps, injectors, and exhaust systems would be replaced by a simple reactor core and electric motor. Applications beyond cars. While the idea of a thorium-powered car is revolutionary in itself, the potential applications of thorium as a fuel extend far beyond the automotive industry. Thorium reactors have been proposed as the future of large-scale energy production, offering an alternative to fossil fuel power plants and even conventional nuclear reactors. In the field of space exploration, thorium's compact, high-energy properties make it an ideal candidate for powering long-term space missions, where carrying large amounts of fuel would be impractical. Challenges and the road ahead. While the future of thorium is undoubtedly exciting, there are still several hurdles to overcome before we see thorium-powered cars on the road. Technology development. The idea of a thorium car is still in its conceptual stages. Developing a reliable, compact thorium reactor that can safely power a car will require significant research and innovation. Advances in materials science, nuclear physics, and energy storage will be critical to bringing this technology to life.